Oops. This is part 4 of thermochemistry. We're going to be looking at molar heats and phase changes. First, let's go over a few definitions. Molar heat of fusion, which we will write as delta H of fusion, is the heat absorbed by 1 mole of solid melting. So here is delta H of fusion shown on a heating curve as we go from solid and gradually melt the liquid. This is your delta H of fusion here. Our typical units are going to be joules per mole, though sometimes you will also see joules per gram or calories per gram used. Related to this is delta H of solidification, molar heat of solidification. So this is when you are cooling a liquid down until it solidifies. This is the heat released by 1 mole of liquid freezing. Again, the units are usually joules per mole, but sometimes you'll see joules per gram or calories per gram. Now notice that once you know delta H of fusion, you also know delta H of solidification, because it's the same quantity of energy. The only difference is going to be the sign. So delta H of fusion you will be putting in heat, so it's going to be a positive delta H. Delta H of solidification is going to have a negative sign as you will be releasing heat. The next phase change that we're going to look at is vaporization. So the molar heat of vaporization, delta H of vaporization, is the heat absorbed as a liquid is converted to a gas. It is related to the molar heat of condensation, which is the heat released by a gas going to a liquid. You're referring to the same region on a heating curve. One is going to have a positive sign and the other is going to have a negative sign. Let's take a look at the units that we're going to use when solving these problems. Joules per mole, we can also think of as being written out as joules per 1 mole of whatever substance it is that we're looking at. Joules per gram would be joules for 1 gram of whatever substance we're looking at. And calories per gram, and I'm going to abbreviate calories CAL, would be calories for 1 gram of whatever substance we're looking at. So these are conversion factors here. And what we're going to do is we're going to solve these problems as unit analysis problems. So let's take a look at this first question. How many grams of ice would be melted by adding 2.25 kilojoules of heat to an ice cube? And it tells us that delta H of fusion is 6.0 kilojoules per mole. This is a conversion factor that we're going to use. When you see this, I want you to think of it as a conversion factor. So think of this as 6.0 kilojoules, specifically for 1 mole of H2O. So let's work the problem. We're going to identify our given, and our given in this case is 2.25 kilojoules of heat. So 2.25 kilojoules. Our find is going to be grams, and it's ice, so it's H2O. So we're going to start this off as a unit analysis problem. We have 2.25 kilojoules, and as with any unit analysis problem, we're going to bring the units down. So we'll bring kilojoules down. We need to get to grams. However, we're going to have to go through moles to do it. So for 1 mole of water to melt, we are going to need 6.0 kilojoules. So we're gotten out of kilojoules, we're to moles of water. We need to get to grams of water. So we're going to bring moles of water down and convert that to grams of water. To do this, we will use the periodic table. If you look on the periodic table, it is 18.02 grams of water for every 1 mole of water. At this point, you're going to multiply everything across the top, divide through by everything across the bottom, and you get 6.76 grams of H2O. Now go ahead and put a box around this so I know that this is your final answer. All right, let's take a look at the second problem here. It says how many kilojoules of heat would be released when 36.04 grams of steam condenses to water at 100 degrees Celsius. This here is telling you that you're at the boiling point of water. You will not actually use this to solve the problem. It's not a temperature change, so you're not going to use Q equals mc delta T. This is a constant temperature. Right here, what they've done is they've given you the heat of condensation, so you should see this as requiring 40.7 kilojoules for every 1 mole of H2O. Now, here this has a negative sign. The released indicates the negative sign here. Since we're going to be looking for heat released, we're going to drop the negative sign. So let's go ahead and do this. Our given is 36.04 grams of H2O. And in particular, it's in the gas phase, so we can go ahead and put that in. So that's in the gas phase. And we are looking for kilojoules. So let's go ahead and start this off. We have 36.04 grams of H2O, or water. We're trying to get to kilojoules, and we have this conversion factor here. We can go from grams to moles. So we've got to get over to moles first. So we're going to have grams of H2O, and we're going to convert that to moles of H2O. So for 1 mole of H2O, we use our periodic table. We have 18.02 grams of water. So we've canceled out our grams of water. We're over to moles of water. Now we can use this as a conversion factor. We're just going to flip the conversion factor over. Well, no, we're going to use it as is, excuse me. So we're going to bring 1 mole of H2O down, and we're going to use 40.7 kilojoules on the top in the numerator. Go through our map, and you get 81.40 kilojoules. Go ahead and put a box around this so that I know you are completely done. All right, I want you to go ahead and try these two using the methods that we just discussed. I've given you the answers there, so go ahead and try them. Then after you're done, we're going to come back and we're going to look at this one and solve it together because there's a little bit of a curveball in this one. So stop. Try it, then turn the video back on and see if you did it right. Here are the worked solutions. So we used the 8.2 kilojoules per mole right here, and here we use 330 joules per mole right here. Now let's take a look at this one here. It's a little different. It says how much heat is required to melt 500.9 grams of ice at 0 degrees C. The heat of fusion of water is 80 calories per gram. I want to bring your attention to this right here. This does not say joules per mole. You have to pay attention to your units. So our question here is how much heat? Well, calories is a unit of heat. So when we're talking about heat here, we're going to have our answer in calories. So our find is actually going to be calories. That's the unit of heat that we're going to look for. The conversion factor that they've given you is that you have 80.0 calories per 1 gram of H2O. So pay attention to your units. So let's go ahead and work this out. This is our given right here, 500.9 grams of ice. So we have 500.9 grams, and ice is H2O, just solid. And we're trying to get to calories. So we're going to bring grams down. So we have grams of H2O. And if we look over here, this allows us to convert directly between grams and calories. So for every 1 gram of H2O, we have 80.0 calories. So if we go ahead and work this out and solve it to the correct number of significant figures, we're going to have 40,000 calories. Go ahead and put a box around it so that I know you're done. So the point here is pay attention to your units. Don't always assume it's going to be joules per gram or joules per mole. Take a look at what you've got and then work with it.